Good morning everyone. So today we are going to discuss about sequential logic circuit, different sequential logic circuits. Okay, so in our last class we have discussed about what? Sequential logic circuit. So what is meant by sequential logic circuit? In sequential logic circuits, present output depends only on the present input as well as the history of previous output also. But in combinational logic circuit, present input depends only on the present output. But in case of sequential logic circuits, the circuits are designed with flip-flops. Combinational logic circuits, basic building blocks are logic gates. Whatever it may be, inside the sequential logic circuit also having gates, but the combinational circuit basically designed with gates, logic gates, whether it may be AND gate or gate not gates or NAND NOR, and also exclusive OR and exclusive OR. Means the basic building blocks of the combinational logic circuits are gates. And here coming to the sequential logic circuit, basic building blocks are what? Flip-flops. So as I said to you in the last class, the differences between the combinational and sequential also over. So what is the main difference between the combinational and sequential? In combinational, the present output depends only on the present inputs. But in the sequential logic circuit, present output depends on the present input as well as the previous. So here there is a need of memory element to store the previous outputs. Okay. But in the combinational logic circuits, no need of saving the previous output, so that no need of memory element is required. And while coming to the next difference, combinational logic circuit, the operation is very speed of operation is there. Why? Because present output depends on only the present inputs. It's not wait for any previous stage outputs. But in case of sequential logic circuits, present stage output depends on previous output now, so that it's wait for getting the output of previous stage, so it becomes slow. So these are the main difference between combinational and sequential logic circuit. And while coming to the sequential logic circuits, these sequential logic circuits are of two types. Okay, already I told you. So synchronous circuits are there and asynchronous are there. So while coming to the synchronous circuits, in synchronous, all flip-flops are clocked simultaneously. Simultaneously means at the same time with same clock pulse, in same level. 5 volts means that 5 volts pulse is applied to all the flip-flops at the same time. But in case of asynchronous counters, only one clock pulse must be triggered with one clock pulse. Okay, one clock pulse must be with okay. In synchronous counters, all the flip-flops must be clocked simultaneously with the same clock pulse. But in asynchronous counters, each and every flip-flop must be clocked with different clock pulses at the different times. So from where we are getting the clock pulse in asynchronous? Where means output of first stage flip-flop acts as a clock pulse for the next stage flip-flop. So in this way, all the flip-flops wait for the previous stage outputs to getting the clock pulse. So automatically in asynchronous counters, the operation speed is slow. But in synchronous counters, the clock must be applied to all the flip-flops at the same time so the operation speed is very high. Okay, sorry. So this is about our last class. In our last class we are also discussed about what is meant by latch. Okay, and how many types of latches are there. So how many types of latches are there? 2 latches are there. NAND latch is there as well as NOR latch is also there. Okay, NAND latch is there, NOR latch is also there. But in NAND latch we are designed the circuit with 2 NAND gates. The output of one gate acts as one of the input of other gates. The output of second gate is connected to the input of first gate. Output of first is connected to the input of second gate. And while coming to the truth table of RS latch, there the both inputs are 0, but having 2 outputs now. Inputs are indicated with S and R, and the outputs are indicated with Q and Q bar. In yesterday's class already it is over. The outputs are complemented to each other, but when we are applying, both inputs are same, whether it may be 0 0 or it may be 1 1, it will violate the law of outputs. Means the outputs are complemented to each other now, but by applying both the inputs are same, the outputs may be same, but it violates the principle of output, so that we ignore these 2 cases. But we consider when S is equal to 1, Q is equal to 1, this condition is called what? Set condition. If S is equal to 0, Q is equal to 0, this condition is called reset condition. Okay, and also we have discussed about flip-flop. What is meant by flip-flop? It is a bistable multivibrator. What is meant by bistable multivibrator? It is used to produce 2 stable states. What are the 2 stable states? One is flip, other is flop. So flip means what? On condition or set condition. Flop means what? Off condition or reset condition. Okay, flip means set or on, flop means reset condition. So how many types of flip-flops are there? In our last class we are discussed now. So RS flip-flop is there, JK flip-flop is there, time toggle flip-flop is there, and delay or data flip-flop also there. And here more one thing is there in our last class, what is meant by clock pulse. Okay, and what is the need of clock pulse? So in all sequential logic circuit they are worked with clock pulse. So what happened without clock pulse? With clock pulse. So without clock pulse, the present stage output may not be produced also. With help of inputs, the circuit will produce the output. What is the theme of sequential? Present output depends on the present input as well as previous output now. But without clock pulse, even though the previous stage output is occurred or not occurred, with help of present inputs it will produce the outputs, so that the errors are produced. So cause of that, here we are using or we are working with the clock pulse. So cause of clock pulse, only the application of clock pulse, the inputs produce the output. If the clock pulse is not applied, even though the inputs are there, the output is not produced. If clock pulse is applied, the output is produced according to the inputs and previous stage output. Okay, so this is the need of clock pulse. And clock pulse is what? Already I told you, clock pulse is a square wave pulse. How many types of triggerings or clockings are there? 2 triggerings are there. So one is called what? Positive edge triggering as well as okay. So in the clock pulse, the triggerings are of 2 types according to their levels and according to the rising edge and falling edge. So according to their levels, two types are there. One is called level triggering. In level triggering, at the positive, so for example this is the clock pulse, positive level triggering is there, negative level triggering is there, and also rising edge triggering is there, falling edge. So in level triggering two types are there, and in edge triggering also two types are there. Level triggering positive and negative, in edge triggering rising edge and falling edge. Okay, and while coming to the level triggering, the output of next stage will be changed only at the levels. If the output is changed at the positive level, then the triggering is called positive level triggering. If the output is changed at the negative level, then the triggering is called negative level triggering. And while coming to the next thing, edge triggering. If the output is changed at the rising edge, then the triggering is called positive or rising edge triggering. What it is called? Positive going clocking or triggering, or rising edge triggering. If the output is changed across the negative level, so then it is called what? Negative edge triggering. Okay, so these topics already we are discussed in our last class. So now we are going to discuss about what? RS flip-flop. Okay, already we discussed about RS latch, so that it becomes very easy. Why? Because RS latch and RS flip-flop both are same. And what is the main theme of designing flip-flop? What is the use of flip-flop? It is used to store one bit. What is the use of flip-flop? It is used to store one bit. Okay, and the flip-flop having how many number of stable states? Flip-flop means it having two stable states. How many number of stable states are there? Two stable states are there. One is called flip and the other is called flap. Okay, and here the flip-flops are designed by using either NAND gates or maybe by using NOR gates. Okay, is it clear? And see here, this is the symbol of RS flip-flop. What it is called? This is the symbol of RS flip-flop. Here, two inputs are there, are indicated with S and R, and the outputs are indicated with Q and Q bar. Inputs are indicated with S and R, outputs are indicated with Q and Q bar. Is it clear? Okay, so next see here, this is clocked RS flip-flop. Clocked means after the application of clock pulse only the output is produced, or the state of the device will be changed from one to other. So actually when S is equal to 1, Q is equal to 1 and Q bar is equal to 0, and S is equal to 0, Q is equal to 0 and Q bar is equal to 1. So according to the truth table, if we apply both inputs are same, that means if both inputs are 0 and 0, the output is possible to produce 1 and 1. Why? Because if any of the input is 0 for the NAND gate, the outputs are high. If any of the input is 0, the outputs are high. But it violates the principle of output snap. Why? Because one output is normal and other is complement of previous one. Both outputs are complemented to each other. But here by applying both inputs are 0, the outputs are not complemented to each other. Outputs also same. So we ignore this condition. The name of this condition is called prohibited condition. Is it clear? Next, after the application of 1 and 0, the Q is equal to 1 and Q bar is equal to 0 with help of clock pulse. If both inputs are 1 and 1, the output is 0. But after application of it to 1, here we are getting Q is equal to 1. Okay, and here it is 1 and here it is 0. If S is equal to 1, Q is equal to 1. Like this, if S is equal to 0, we are getting Q is equal to 0 and Q bar is equal to 1. Okay, in this way the clocked RS flip-flop must be worked. Is it clear? Okay, so in this way the RS flip-flop works. For application of S, Q is equal to 1. For application of S is equal to 0, the Q is equal to 0. If both inputs are 0, there is a possibility of producing both outputs are high, but it violates the principle of output, so that we can ignore this case. Okay, and while coming to the next one, if we are applying S is equal to 1, okay, cause of clock pulse is applied, both are high, it gives 0, and if any of the input is 0, in the next stage it will produce 1. That means what? If S is equal to 1, Q is equal to 1. If S is equal to 0, here we are getting Q is equal to 0. So if S is equal to 1, if we are producing Q is equal to 1, that state is called set condition of the flip-flop. What it is called? Set condition of the flip-flop. If it is not produced means, okay, if S is equal to 0, Q is equal to 0 means reset condition. And here what is the main use of clock pulse? If the clock pulse is applied means, in presence of clock pulse only, the input are able to produce the outputs. Without giving clock pulse, even though the inputs are applied, the output is not produced. So this is the use of clock pulse. Is it clear? Okay, see here. One second. Sorry. Okay, and while coming to the next one, see here. What happened? One second. Here some problem is there. Okay, see here. So this is the truth table of our NAND gate. This is the truth table of SR flip-flop. So see here, if clock pulse is 0, 0, 0, 0, in 4 cases. First, if clock pulse is 0, both inputs are 0, the output is not changed. If S is equal to 1 also, the output is not changed. If R is equal to 1 also, the output is not changed. If both are high also, the output is not changed. But if the clock pulse is applied, then the outputs are changed according to the inputs. If clock pulse is 0, the outputs are not changed. Outputs are not changed even though the inputs are present. But if the clock pulse is applied, outputs are changed according to their inputs. Okay, so see here, if the clock pulse is high, the S is equal to 1. Now we are getting Q is equal to 1. So this condition is called what? Set condition. This condition is called set condition. And if R is equal to 1, S is equal to 0, then we are getting normal output Q is equal to 0. So this condition is called what? Reset condition. And in the last case, both are high means no output is produced. So this condition is called what? Prohibited condition. This condition is called what? Prohibited condition. Okay, and see here, these are the clock pulses of RS flip-flop. These are the clock pulses of RS flip-flop. So for the application of first clock pulse, when we apply the inputs, S is equal to 1, high level input, see here, this is high level, okay, and R is equal to 0, S is equal to 1, here we are getting Q is equal to 1, okay. In next stage, we are applying S is equal to 0 and Q is equal to 1, what we are getting here? Q is equal to 0. So this condition, if S is equal to 1 and R is equal to 0, this condition is called what? Set condition. If S is equal to 0, R is equal to 1, we are getting 0. This condition is called what? reset condition of the flip-flop. So this is about what? Clock pulses. This is about what? Clock pulses. Okay. When we apply the clock pulse, and after application of the clock pulse, if we apply the main input, set input is equal to 1, we are getting the output, Q output, that is equal to 1. If we apply the okay, so if we apply the S is equal to 1, then the normal output Q is equal to 1. That state is called what? Set condition. If S is equal to 0, R is equal to 1, then we are getting normal output is equal to 0. This condition is called reset condition of the flip-flop. Reset condition of the flip-flop. Okay. And while coming to the next one, that is called JK flip-flop. What is the name of our next flip-flop? JK flip-flop. So the JK flip-flop is made from the refinement of RS flip-flop. And why we are designing JK flip-flop? Already RS flip-flop is there now. Of course RS flip-flop is there here, but here RS flip-flop having one drawback. So what is the drawback means? In RS flip-flop, okay, in RS flip-flop, for the same inputs, whether it may be 0 0 or it may be 1 1, the output is in hold condition now. It is unable to change. So that to avoid that case, here we are designing with JK flip-flop. Okay, so here the JK flip-flop is having the feature of SR as well as T flip-flop also. Sometimes it is also called universal flip-flop. Why? Because here no hold condition or no wait or no change condition is there. Okay, so that's why it is also called what? Universal flip-flop. When R is equal to S is equal to 1, the state of output is changed in the JK flip-flop. But in previous case, in RS flip-flop, if R is equal to S is equal to 1, the state of output is not changed. It fall in hold condition now. But here, when R is equal to S is equal to 1, the state of output is changed. That means that is the complement of previous state is available. That is the complement of the previous state is available. And see here, Qn be the output at a given time in the nth interval preceding the nth clock pulse. Okay, and here Qn plus 1 is the corresponding output in the interval immediately after the nth pulse. Qn plus 1 is the corresponding output in the interval immediately after the nth pulse. Okay, and in JK flip-flop, see here, these are the clock pulses produced after the application of input. For the first clock pulse, the output is high, and for the second R is equal to 0, the output is low. But when both inputs are high, now the output is changed, not in hold condition. Okay, see here, this is the block diagram or the logic diagram of JK flip-flop. How the JK flip-flop is designed? Once see, the JK flip-flop is designed by adding 2 AND gates to the RS flip-flop. How it can be designed? It is one RS flip-flop with 2 AND gates. By adding 2 AND gates to the RS flip-flop, JK flip-flop must be made. By adding 2 AND gates to the RS flip-flop, JK flip-flop must be constructed. So where we can add these 2 AND gates? For the S input, one AND gate is connected. For the R input, the RS flip-flop, second AND gate is connected. For the first AND gate, the J input main input is applied. Okay, for the first AND gate, gate 1 and gate 2. For the gate 1, one input is J and gate 2, one input is K. And for the gate 1, second input is came from the output of the RS flip-flop. And for the second gate also, second input is came from the second input of RS flip-flop. And third input for both AND gates is clock pulse. So finally, two AND gates having three inputs. One is clock pulse, that is common for both gates. Other is two main inputs, one is J and other is K. And next third input for two AND gates came from the output of the next stage. Is it clear? Means the output is connected back to the input. Output is connected back to the input. So here Q bar is connected to the J. Q bar is connected to J and Q is connected to K. Means Q is connected to second gate. Q bar is connected to first AND gates. Okay. This is the block diagram of our JK flip-flop. How many number of inputs are there in JK flip-flop? Two inputs are there. And how many number of outputs are there? Two outputs are there. In which fashion the inputs and outputs are connected? And the output is connected back to the input of first gate. And Q bar output is connected to the input of second gate. And the clock pulse must be connected to both gates. And the main inputs are connected to gate 1 and gate 2. Okay. And how many number of outputs are there? Two outputs are there. What are the two outputs? Q and Q bar. Okay. And this is the symbol of JK flip-flop. The symbol indicates only inputs and outputs. How many number of inputs are there? Two inputs J and K. How many number of outputs are there? Only two outputs Q and Q bar. And the clock pulse is common. Okay, clock pulse is common. So this is about what? The construction and also the operation of JK flip-flop. So now this is the truth table of JK flip-flop. So while coming to the JK flip-flop, here the JK flip-flop is having two inputs. JK flip-flop having two inputs J and K and two outputs Q and Q bar. The two inputs J and K, are applied with help of what? Clock pulse. With help of what? Clock pulse. Okay. With help of clock pulse, if we are applying two inputs J and K, the output must be changed. Here the JK flip-flop is designed with help of RS flip-flop by adding two gates. So the two gates having three inputs, the clock pulse acts as one of the input for two gates and two main inputs are applied, and the third one is the output is connected back to the two gates. Okay, and this is the symbol of JK flip-flop. How many number of inputs are there in JK flip-flop? Two inputs are there in JK flip-flop. What are the two inputs in JK flip-flop? J is 1 and K is 1. And how many number of outputs are there? Two outputs are there. One is Q, other is Q bar. The outputs are complemented to each other. Okay. when the application of clock pulse according to the inputs, the output is changed. And see the truth table. So this is the truth table. In truth table, if we apply J is equal to 1, the output Q is equal to 1. In the application of J is equal to 0, the output Q is equal to 0. If J is 1 only, we are getting Q is equal to 1. If J is equal to 0, we are getting Q is equal to 0. If both are high, this is a special condition. If both are high, the output is toggled from 0 to 1 and 1 to 0, 0 to 1 and 1 to 0. This condition is called what? Toggle condition. This condition is called toggle condition. Is it clear? And see here, this is the simplified version of the gates. This is the simplified version of the truth table. According to the logic symbol, it is designed. So once see, this is the logic symbol of JK flip-flop. How many number of inputs are there here? 2 inputs are there. What are the 2 inputs? J and K. And how many number of outputs are there here? 2 outputs are there. What are the 2 outputs? Q and Q bar. Okay. According to the logic diagram, here simplified truth table is there. So see here, in simplified version, if clock pulse is 0, if both J and K is 0, no change condition occurred. If J is equal to 0 and K is equal to 1 also, again no change condition occurred. If J is equal to 1 and K is equal to 0 also, no change condition. If both are 1 also, no change condition. That means what? If the clock pulse is not there, in the case of absence of clock pulse, even though the inputs are applied, the output is not changed. Even though the inputs are applied, the output is not changed. But in case of clock pulse, if we apply the clock pulse, according to the inputs, the state of the output is changed. So see, if the clock pulse is applied, for application of K input, we are getting Q bar is equal to 1. This condition is called what? Reset condition. If J is equal to 1, we are getting Q is equal to 1. This condition is called set condition. Main condition of JK is toggle condition. When both inputs are high and if we apply the clock pulse, the toggle condition is occurred. Toggle means the output is not hold condition changed from 0 to 1 and 1 to 0, 0 to 1 and 1 to 0. Okay. So to eliminate the hold condition during the application of both inputs are high, here we are designing the JK flip-flop. So in presence of both inputs are high, the output is changed from 1 to 0 and 0 to 1. This condition is called what? Toggle condition. This condition is called what? Toggle condition. Okay, see here. So next topic is what? Preset and clear inputs. So what are the next condition? Preset and clear inputs. Now, so here coming to these 2 inputs, these 2 inputs are called special inputs. Now see here, these are the two special inputs. So what is the need of these two special input means, in previous either SR flip-flop or JK flip-flop, the output is changed only during the application of clock pulse. For example, if I want 1 only for the application of J is equal to 1 and we are getting previous stage output only, the output is equal to 1. But here in the case of preset and clear inputs, even though the inputs are not changed and even though the output is not changed, directly we are getting the set condition or reset condition according to our requirements. Okay, in case of preset and clear inputs, even though the inputs are not present and irrespective of the output of the previous stage, the present input either may be set to 1 or it may be set to 0. If the present input is set to 1, that condition is called what? Preset condition. If present input is set to 0, that condition is called reset. So how we are getting these two set and reset condition directly means, by the application of preset input we are getting set condition, by the application of clear input we are getting reset condition. Okay, so this is the main use of preset and clear inputs. Is it clear? So to get the output is equal to 1, directly we are applying the preset inputs, clock pulse across the preset input. If we applying the output is equal to 0, we apply the clock pulse across the clear. Okay, by application of clock pulse across the presets we are getting the output 1. By apply the clock pulse across the clear we are getting the output is 0. Okay, so if we are getting the output 1, that condition is called set condition. If we are getting the 0, that condition is called reset condition. So now see, this is the symbol of JK flip-flop with preset and clear inputs. So see here, with the application of clear, what we are getting here? If both are high, nothing is changed. But if preset is equal to 1, we are getting Q is equal to 0, and clear is equal to 1, we are getting Q is equal to 1. So for this purpose, here we are working with what? Clear and preset inputs. Is it clear? So this is about what? The two special inputs, clear and preset. By the application of the clock pulse across the clear and preset, here we are directly changing the state of the flip-flop, either directly to the set condition or directly to the reset condition. Is it clear? And see here, the presets and clear data inputs are called either direct input or synchronous input. So see here, why these are called direct input? Why these are called direct input? By the application of preset and clear, we are directly change the output now, irrespective of inputs and previous output. That's why these inputs are called direct inputs. Is it clear? By the application of these input, the output is directly changed. That's why these inputs are called direct inputs. And why these are called asynchronous inputs? Irrespective of clock pulse, these are working now. Even though the clock pulse is present or even though the clock pulse is not present, by the application of these two inputs, preset and clear, the output is changed directly. The output is changed directly. So that these inputs are called either direct inputs or asynchronous. Why these are called direct means, by the application of these inputs, the output is directly changed irrespective of the input and clock pulse. Why these are called asynchronous? By the application of these inputs, the output is directly changed irrespective of the clock pulse. That's why these are called asynchronous. And these inputs are never synchronized with clock pulse. Means even though the clock pulse is present or not present, also they produce the outputs. Means they work directly. That's why these are called asynchronous inputs. Of course, in presence of these inputs, clock pulse may be present, but don't bother about the clock pulse. And see here, if the output of flip-flop is set to 1 by activating the preset inputs, when we are getting one output by activating preset input. How can we activate the preset input? By applying the clock pulse to the preset input. Okay? And how can we reset it to 0? By activating the clear inputs. Okay? So how many number of inputs are there? 2 special inputs. How can we are getting the output of flip-flop directly to 1? By the application or by activating the preset input. How can we are getting a 0? By applying the clear input. Is it clear? So this is about 2 special input. So in today's class we are discussed about what? RS flip-flop, JK flip-flop, and also the special inputs. Okay, see here 2-3 questions are there, multiple choice questions. Why? Because D is common subject to all the people, and we are must and should we are facing multiple choice questions in your competitive examinations from DE. And see, while coming to the flip-flops, first question is, name the flip-flop which has racing condition. So which flip-flop has in racing condition? JK flip-flop. Okay, RS flip-flop. And how can we eliminate that racing condition? With the help of JK flip-flop. In JK flip-flop, which condition is there? Toggle condition is there. Okay. And how can the toggle condition is eliminated? That we discussed in next class with help of master-slave JK flip-flop. Okay. So this is about what? Racing condition means even though the 2 inputs are high, the output is not changed, that is in hold condition. So that condition is called what? Racing condition. Okay. So in today's class we have discussed about what? The main topics of today's class is main topics of today's class is what? RS flip-flop, construction, symbol, truth table, and also JK flip-flop, construction, symbol, truth table. So while coming to the construction of RS flip-flop, okay, in RS flip-flop main 2 inputs are there. One is called set and other is called reset, and having 2 outputs Q and Q bar. When R is equal to 1, the output Q is equal to 1 is produced, and when R is equal to 0, the output, normal output, is equal to 0. If R is equal to 1, complement output is high. If S is equal to 1, if we are getting Q is equal to 1, the state of the flip-flop is called what? Set condition. If S is equal to 0, R is equal to 1, if we are getting Q bar is equal to 1, that condition is called reset condition. But one drawback of the RS flip-flop is what? If both inputs are high, the output is in hold condition. Even though the next, if we change the inputs, output may not change. After restarting only, it is able to produce the output by reacting it to the input. Okay. But here in JK flip-flop, even though the inputs are same, the output is not in hold condition. Output is not in hold condition. The output is changed according to the inputs. In JK flip-flop, it is designed with SR flip-flop having NAND AND gates at the inputs. How the JK flip-flop is designed? The JK flip-flop is designed by adding 2 AND gates across the SR flip-flop. And these 2 AND gates are having how many number of inputs? 3 inputs. So one is clock pulse, that is common, and it is applied to both gates. And other are J and K inputs, they are directly applied to the AND gates. And the third one is came from the output of previous stage. First gate getting the output Q bar is, and second gate we have to connect Q is to the. So here the output is produced depends upon the history of previous output. So main advantage of JK flip-flop is what? Hold condition is eliminated. So what we are occurring at both inputs are high, toggle condition is occurred. Okay, some development is there, but irrespective of the inputs and outputs also, we make it the output of flip-flop is either 1 or 0 with help of two inputs, two special inputs. The name of the two inputs are called clear and preset. The name of the inputs are called clear and preset. Okay, so in case of the clear and preset, even though the main inputs are present, the state is changed according to the clear and preset only. If we want to get 1, we activate or we apply the clock pulse across the preset. If we want to get 0, you activate the clear, that means you apply the clock pulse across the clear. Even though the J is present, K is present, but the circuit state is changed according to the clear and preset only. If clear and preset are there in circuit, the circuit works with only clear and preset. If clear and preset are not there, or if we are unable to apply the clock pulse across the clear and preset, then the circuit state is changed according to their normal inputs and clock pulse. And cause of this direct change in state means directly the circuit responds to the clear and preset. These inputs are called direct inputs. And more thing is also there. Cause of these two inputs are not synchronized with clock pulse. Means even though the clock pulse is not there, and also even though it is there, they produce the output directly. They produce the output directly. That's why these inputs also called asynchronous inputs. Why? Because these are not synchronized with the clock pulse. That's why these are called what? These clear and preset inputs are called what? Direct inputs, and also called asynchronous inputs. Why these are called direct? By the application of these inputs, the output is directly changed irrespective of the inputs. Why these are called asynchronous? The output is changed irrespective of the clock pulse. Even though it is present or it is not present, they will change the state of the output. Is it clear? So, and while coming to the previous questions or coming questions, upcoming questions, 5 marks questions are explain the working of JK flip-flop with neat sketch, and explain the working of RS flip-flop with neat sketches. Means what? Explain the working of RS flip-flop with its truth table and diagram, and explain the working of JK flip-flop with its truth table and circuit diagram. And 3 marks questions, state the need of preset and clear inputs. Okay, this is the main theme of. And while 1 mark question is very important question, how the hold condition in RS flip-flop is eliminated? What is our answer? The hold condition is eliminated with help of JK flip-flop. So in JK flip-flop, what is meant by toggle condition? For both inputs are high, the output must be changed from 0 to 1 and 1 to 0. So this condition is called what? Toggle condition. Okay, so this is about today's class. Now I would like to conclude it.